Hello and welcome to the presentation of a question of Fidelity comparing different user testing methods for evaluating in-car prompts, a work conducted by myself, Anna-Maria Meck, and my colleagues Christoph Draxler and Turit Vogt in a collaboration between the LMU Munich and its Institute of Phonetics and Speech Processing and the BMW Group. The motivation behind this project is as follows. User testing is a major step in any user-centered design process to validate HCI concepts before large product rollouts. Testing methods thereby vary greatly regarding the organizational, financial, and timely efforts which are needed to conduct them. In general, two testing types can be differentiated, namely high and low fidelity testings. High fidelity testing environments already display the environment a product will later be used in, whereas a low fidelity testing setting lacks this degree of product maturity. Thinking about both testing methods as being two ends of a spectrum, timely monitoring organizational efforts rise the more you go into a high fidelity direction. In automotive settings, high-fidelity testings are especially draining on resources because a driving task needs to be simulated. We want to know if this effort is justified and ask the question if low-fidelity testing methods are a valid alternative for high-fidelity testing of voice prompts for in-car contexts. To answer this question, we conducted a between-subject study tasking study participants with evaluating proactive voice assistant system outputs, so-called prompts. In total, there were 3 groups. 2 groups conducted an online crowdsourcing study without any immersive elements, so a low-fidelity study. One of those groups received the prompts they were to evaluate it in text form. The other group received them via audio. A third group was invited to a driving simulator with a stationary vehicle mock-up with a 180-degree screen and a highway setting with low traffic, so a very high-fidelity study setup. We found that there were no significant differences between a text-based online crowdsourcing and a driving simulator study with a Z ratio of 0.8 and a p-value of 0.7. Looking at general ratings and naturalness ratings of prompts, we see that means in the text and the simulator condition do not differ from each other, but we see that prompt evaluations in the audio condition are different from the text and the simulator condition. To explain our results, we fell back on a psychological model, the so-called elaboration likelihood model, or short ELM. The ELM explains how recipients of any message will process this message by defining 2 different so-called routes for processing information, the central route of processing and the peripheral route of processing. In the central route, processing is based on the true merits of the information presented, so on the contents of a message. In the peripheral route, processing is based less on contents and more on affectional or so-called peripheral cues, which can be a number of things like, for example, the likability of a source the information comes from or the likability of a voice. Key factors now for choosing a route are the ability to process a message, as well as the motivation to do so and the amount of cognitive resources one needs to or is willing to allocate to the processing task. Lastly, in order to be able to choose the peripheral route of processing, peripheral cues have to be available. Moving through the chart, the red arrow stands for the simulator condition, the blue arrow marks the audio condition, and the green arrow marks the text condition. Now, the ability to process prompts was given for all testing conditions, audio, text, and simulator. The motivation is the first differentiating factor, though. Study participants in the simulator condition are highly motivated to process a prompt because it is potentially crucial for their driving task, which is why they pay attention to the contents of a prompt and choose the central route of processing. Study participants in the audio and the text condition do not feel this immediacy and are hence less motivated to allocate considerable cognitive resources to process a prompt. Now, processing audio is more challenging than processing text, and processing audio is also accompanied by peripheral cues in form of a TTS. For the audio condition, study participants were hence led to the peripheral route of processing, while study participants in the text condition took the central route of processing, like their counterparts in the simulator condition, which explains why prompt evaluations did not differ between a text-based crowdsourcing study and a simulator study. We conclude that less time and cost-consuming crowdsourcing studies are hence as valid as high-fidelity simulator studies for prompt text evaluation. And with that, I'm very much looking forward to hopefully vivid discussions around that topic, and thank you very much for your attention.